Hello! So today I'm going to talk about significant figures. So if we tell someone that we have 5 pennies or 5 quarters, our meaning is clear. We usually when we talk about pennies or quarter, we talk about it as a whole. So when we say 5 pennies, we mean that it is like 5 penny, not 5.4 or 5.2 pennies. It is really unlikely that we would tell someone, oh, we have 5.2 pennies. But if we tell someone that we have 1 kilogram of salt, we are not sure, like the meaning is unclear whether it is 1.0 kilogram of salt or 1.5 kilogram of salt or 1.583 kilogram of salt. So this is when significant figures come into place. So significant figures represent the precision of a measured quantity. So what are the rules of significant figures? Rule number 1, all non-zero digits are significant. Number 2, interior zeros are significant. Number 3, trailing zeros are significant if after a decimal place, before a decimal place. And the last rule is leading zeros are not significant. So this is an example of leading zeros, interior zero, trailing zero, and the non-zero digits look like. So trailing zeros after a decimal point are significant. For example, this number right here, 35.00. So these 20 is significant, which means that we're going to have 4 significant figures. Trailing zeros before decimal point are also significant. So what we are talking about is this 0 right here before the decimal place. So in this case, we're going to have 5 significant figures in totals. Trailing zeros at the end of a number before an implied decimal point are ambiguous. For example, 350. So this 0 is ambiguous. We don't know how many significant figures it is. It could be 2 significant figures, or it can also be 3 significant figures. Exact numbers. So exact numbers have an unlimited number of significant figures, and it originates from exact counting of objects. For example, 3 apples mean 3.0000 apples. It's exact. It also comes from defined quantities, something like 1 meter equals 10 decimeter or 1 meter equals 100 centimeter. It's going to be equal to like 100.000 centimeters. It also comes from integral numbers that are part of an equation. So if you look at the equation radius equals diameter divided by 2, the number 2 is exact and it has unlimited significant figures. How do you count significant figures during an addition and a subtraction? So one simple rule that I usually use is that the significant figures of the result, it has to follow the number with the fewest decimal places. So if you look at this example right here, so 2.345, you have 3 decimal places after the number 2, and then 0.07, you have 2 decimal places. 2.9975, you have 4 decimal places. So when you add all of them up, you have 5.4125. So how many significant figures are you going to keep? So you're going to follow the number that has the fewest decimal places, which is 0.07 here. It has 2 decimal places. So your answer has to have 2 decimal places as well. So to conclude, 5.41 is going to have 3 significant figures. How about multiplication and division? So multiplication and division is a little different from addition and subtraction. So the significant figures of the result, it has to follow the number with the fewest significant figures. So if you look at the example, we have 1.052. It's going to have 4 significant figures, times by 12.504 with 5 significant figures, times by 0.53 with 2 significant figures. So when you time all of them together, you're going to get 6.7208. How many significant figures are you going to keep? You're going to follow the 2 significant figures, the fewest significant figures. That's why I have 6.7 as my answer. So another thing is, how do I get only 2 significant figures right here? So if you look back to the rules, we mentioned that leading zero is not important. So D0 is called a leading zero and it's significant. That's why we start counting from 5 and 3, so it makes it 2 significant figures. Rounding. So you round down if the last digit drop is 4 or less. And you round up if the last digit drop is 5 or more. For example, rounding these numbers to 2 significant figures. So 1.73, so the last digit is 3. That means you have to round down, which make it 1.7. But the second example, you have 1.77. So this is above 5. It is more than 5. So you have to round up, which make it 1.8. What about if you have addition or subtraction with multiplication or division at the same time? What should you do about the significant figures? So let's do an example. Let's say we have 1.257. So let's do plus 2.58 times by 0.50. So according to the order operation, we have to do the numbers in parentheses first. So in this case, we're going to add these 2 numbers first. So 1.257 plus 2.58. So you will get 7, 3, 8, and 3. So you will get 3.837. However, how many significant figures are you going to keep? So according to the addition rules, we have to follow the fewest decimal places. So in this case, this number has 3 decimal places. This one has 2 decimal places. So our answer is going to be 3.83. However, because after the 3 is 7, which is more than 5, we have to round these up. So it's going to be 3.84. Usually when you do addition or subtraction, you can also draw a line like this, so that you will know which one has the fewest decimal places, and then just follow that. In this case, when you draw a line that follows the fewest decimal places, you would get 3.83 or 3.84 as your answer is after rounding up. Now, when we've got 3.84, it's going to time by 0.50. I'm going to use calculator for this. 1.92. Now, how many significant figures are we going to keep? So, for multiplication, it has to follow the fewest significant figures. In this case, 3.84 gives us 3 significant figures. but 0.50 only gives us 2 significant figures, which means that our answer is going to be equal to 1.9. Said about significant figures, I admit that chemistry is hard, but it's not impossible. I can do it, and so can you. Practice makes perfect. And don't compare yourself with other people. Your progress is your progress. It does not matter how slowly you go as long as you do not stop. Bye!